Hello everyone, my name is Pipin Abram and in today's video we will do some sample practice questions on chapter number 3, that is current electricity, and this is just the part 1 of the video. So we'll be releasing more and more videos on your question paper practice. Okay, so let's get started with our first question. The first question is, the current in a wire varies with time according to the equation I is equals to T plus 1. So your current is a function of T plus 1, right? Function of time. T is where time and I is obviously the current, where I is in ampere. Yes, I is actually the current, so that is it is in ampere, and T is in seconds because it is time, right? The quantity of charge which passes through a cross section of the wire during the time, the limits are given to you. T is equals to 2 seconds to T is equals to 6 seconds. You have 4 options here. A is equals to 40 coulomb, B is equals to 48 coulomb, C is equals to 20 coulomb, and D is equals to 46 coulomb, right? So basically a simple question. We all know current is given as rate of change of charge with respect to time, right? This is how you actually define current. Now the value of current is actually a function of time according to our question, that is I is equals to T plus 1. I is equals to T plus 1, right? Okay, so the current is given to you and you're supposed to find out the value of charge which passes through a cross section, right? So obviously we can simply find that out. How we can find out? Instead of I, we can put T plus 1, and that is equals to rate of change of charge per unit time, right? So I can write it down further. T plus 1 is equals to dq upon dt, right? And just cross multiply it. This is T plus 1 times of dt is equals to dq, right? And integrate it both sides. Now by integration, so when you do the integration, you will get integration of T plus 1 dt is equals to integration of dq, right? Okay, now the limits are given. T is equals to 2 seconds to 6 seconds. So just apply the limits here. This is 2 to 6 second. T plus 1 dt is equals to the charge which will pass through, right? So I can just solve it here. So this will be simply equals to, so integration of 2 to 6, this is T dt, plus integration of 2 to 6, this is 1 dt, and that is equals to the charge. Or I can simply say this is T square by 2. When I integrate it, you will get from 2 to 6 the limit, plus integration of 1 dt will be simply equals to T, and limits are from 2 to 6, and that is equals to your charge. So just apply the limits here. Upper limit minus lower limit, this will be 6 square upon 2 minus 2 square upon 2, right? This is plus, this will become 6 minus 2, right? So let's just see what is the final answer here. This is 36 by 2 minus 4 by 2 plus 6 minus 4 is 6 minus 2 is actually 4. So this is 2 times 4, 18 times of 16, sorry 36. So 18 minus 2 plus 4. This comes out to be 20 coulomb. So the charge over here is 20 coulomb, right? So let's see if it is there in our options. Yes, 20 coulomb, option number C. So option number C is our answer, that is 20 coulomb. All right, great. Let's move to our next question. Next question says, yes, which of the following characteristics of electrons determines the current in a conductor? This is NCERT's exemplar problem. So which of the following characteristics of electrons determines the current in a conductor? So you have 4 options here: drift velocity alone, thermal velocity alone, both drift velocity and thermal velocity, neither drift nor thermal velocity. So basically we're talking about which of the following characteristics of electrons determines the current in the conductor. So we have studied the drift velocity topic. So whenever you have a conductor, right, this conductor will have lots and lots of free electron, right? So the question is asking us about the current, right? So we already know from the drift velocity concept that current can be given as VDENA, right, where your VD is actually the drift velocity, right? E is your charge of electron, What is N? N is your number of electrons per unit volume. What is A? A is your area of cross section. Area of cross section of the, this one material we're talking, right? Okay, now also from here we can actually see drift velocity is also given as E times of capital E upon m times of tau, right? Okay, now the question is, which of the following characteristics of electron determines the current in a conductor? We're talking about the current here, right? So drift velocity, yes, because in the current equation there is this drift velocity. So drift velocity will actually, play an important role here when we talk about the current, right? Second, thermal velocity. Now, if you guys have studied the drift velocity concept, then we know thermal velocity is the velocity of, environment, that is your room temperature. So because of the room temperature, and let's say we haven't connected with some kind of energy source, some kind of battery source, so there is no electric field. So when there is only room temperature, these free electrons gains energy because of the free room temperature, and they start moving in random direction, right? So if this electron moves in this direction, there will be other electrons which will be moving in opposite direction. And if I talk about the entire velocity of the entire conductor, then that comes out to be 0. So I can simply say that thermal velocities do not contribute to the actual velocity of electrons because of which the current is produced, right? So thermal velocity will not be answered. Drift velocity, because it is there, we have derived the formula, it is there in the current equation. So drift velocity is something on which it depends. Thermal velocity, at which the current is not depending much. Both drift velocity and thermal velocity, not both, but drift velocity can be the answer. Neither drift velocity nor thermal velocity, this is also not the answer. The answer is that it actually depends upon the drift velocity alone. I hope that is understandable, right? Okay, let's move to the next question. Yes, this is question number 3. If an ammeter in the given circuit shown in the diagram read 2 ampere, the resistance R is. This came in CBSE sample question paper 2020. So you have 6 volt, cell, you have an ammeter connected to it, you have two R, you have resistance of 2R, and you have one more resistance of R, right? So the 4 options are there. What is the value of R is, that is what the question is asking. The values are 1 ohm, 2 ohm, 3 ohm and 4 ohm, right? Okay, so basically I have these two resistances in series. So when they are in series, I can simply say I can replace them with a equivalent resistance, right? And obviously the value of equivalent resistance will be simply 3R, because in series the resistances adds up, right? Yes or no? So you have this ammeter, right? This ammeter is actually showing you the value of current. The work of ammeter is to measure the current inside the circuit, right? So you have 6 volt, cell supply, or you can say battery supply, right? And the ammeter is reading 2 ampere. That means 2 ampere current is being flowing here. 2 ampere current is being flowing here, right? So 2 ampere current is flowing. Okay, now the question is asking us to find out the value of R, right? So how we can do it? I can simply use Ohm's law. Ohm's law states that the potential, or I can say the current that is flowing through this resistance is directly proportional to the potential difference, or I can simply say V is equals to I times of R. V is given to us, that is 6 volt. I is also given to us, that is 2 ampere, and the value of resistance is 3 times of R, right? So from here I will get 6 is equals to 6 times of A, 6 times of R. So from here you will get, from here you will get 6 is equals to 6 times of R, right? Or you will get R is equals to 1 ohm. I hope you guys can understand. So the value of resistance is, the value of R is actually 1 ohm, which is there in our option, that is 1 ohm. I hope that is understandable. Let's move to our next question. Question number 4. So you have the current I in the circuit. the current I in the circuit. So you have given this circuit here, you have to find out the value of I current, right? Again, simple question. You have these resistances here, right? You have these resistances here. All I have to do is, instead of putting it like that, I will talk about an equivalent resistance here. So you have to understand these two resistances are in series and this one is parallel with these two resistances. Can you guys understand that? So I can basically redraw this figure. Let me just redraw this figure here. So I'll just simply redraw this figure. Before redrawing, I'll just name everything. This is A, B, and this is C. So let me just very simply name this. So I have A point here, I have B point here, right? Okay, all right. So from A to B, I have a resistance and the value is 30 ohm, right? And here I have two resistances just like that. And you have again 30 ohm, right? In between you have this point C. I hope you guys can understand that, right? And this entire thing is connected with a battery source, or I can say cell source of 2 volt, right? 2 volt. It's connected like that, right? I hope you guys can understand that. Very good. Now you're supposed to find out the value of I in the circuit. The value of I is something which I am to find out. So very simple, very simply I can do this. How I can do that? See, this 30 and 30, they are in series, so it will automatically become 60 ohm if I talk about the equivalent resistance here, and it is connected with a parallel resistance of 30 ohm, right? So I'll just first find out the value of equivalent resistance here. So I can simply find out 1 upon 60 plus 1 upon 30, that is equals to the 1 upon R equivalent, right? And this will be equal to 60, and this will be equal to 2 plus 1 is equals to 1 upon R equivalent, or simply I can say 3 upon 60 will be equal to 1 upon R equivalent. This is 3 one time, 3 2 times, 20 times, right? This is 1 upon 20 is equals to 1 upon R equivalent, or I can say R equivalent will be equal to 20 ohm. So I got the value of R equivalent, that is your 20 ohm. So I can redraw this again with one equivalent resistance here. So I have this equivalent resistance that is equal to 20 ohm, right? And this is connected with a battery source of 2 volts, right? Okay, now obviously the current will flow like that, yes or no? And again, once again, I can use Ohm's law to find out the value of current. V is equals to I times of R. V is given 2 volts. I is something which I am to find out, and R is actually 20 ohm. So I can simply write it here. I will be equal to 2 upon 20 ampere. 2 one time, this is 2 10 time. So I will be simply equals to 1 upon 10 ampere. And that is, yes, it is there in our option, that is 1 upon 10 ampere. Yes or no? I hope that is understandable, right? Okay, great. Let's look at our fifth and final question of this video. So in the following graph, identify the region where Ohm's law is obeyed. Okay, so you have current over your y-axis, you have voltage over your x-axis, right? And this is the graph here, you guys can see that, right? So I have different regions here, A, B, C and D. So I have to find out that which region obeys Ohm's law. All right, now if we remember correctly, Ohm's law was that through a resistor, obviously some current will be flowing through the resistor, and the current that is flowing through the resistor, the conductor, is directly proportional to the potential difference across it, right? That is, as you increase the value of current, your V should also increase, or as you increase the value of voltage, your I should also increase. This is something which we have to see in the graph. So let's look at our AB region. So when we look at AB region, as you go in the direction of voltage, as you go in the increasing direction of voltage, the current is actually increasing. Yes or no? And that is what your Ohm's law is, that current will be increasing as the voltage is increased. Yes or no? So I can very nicely see here that this region is obeying Ohm's law. What about your BC region? So as your voltage is increased, your current, you guys can see for a very short time it is increased, and then it is constant for some time, and now it is decreased. So this BC region is not following Ohm's law. I hope you guys can understand. Let's talk about our CD region. What is happening in CD region? So in CD, as you're increasing the voltage, the current is actually decreasing. Can you guys see that? I'm increasing the voltage here. The current is decreasing, right? So this is very important. You know, this CD is a very important part of this graph, because you guys can see here in CD graph, or I can say the CD part of the graph, CD part of the path, right? The resistance is actually negative. Here you have to understand, your resistance is negative here. Why the resistance is negative? Because as you are increasing the voltage, your current is dropping. Yes or no? Your current is getting dropped, right? So it is just opposite to that of your Ohm's law. So Ohm's law was that if you increase the value of current, your voltage should increase, right? And this is only happening in your this section, A to B. Yes or no? In B to C, it's increasing first, then decreasing, and in C to D, as the voltage is increased, the current is reducing, right? I hope you guys can understand. So the answer to this question is A to B. Yes, A to B portion, right? I hope that is understandable. Yes, I hope that is understandable. So if you have any doubt, you can comment it down in the comment section. We will be coming with more and more practice questions. So stay tuned. Thank you and have a nice day.